Okay, so our video notes are going to be about parallel and perpendicular lines, since you already know how to graph and write linear equations, which we did in class today. Um, the first situation, I know everybody knows parallel lines never intersect, blah, blah, blah. But what you guys need to take away since you're in algebra is that parallel lines never intersect because their slope is the same. So if you look at this situation right here, both of these have a slope of 2 and different y-intercepts, which is what's making them never cross because they're growing at the same rate. Perpendicular lines, on the other hand, have the property that their slopes are opposite and reciprocal. So opposite meaning that if one of them has a slope that's positive, then the other one has to have a slope that's negative. That's the only way to get them to go in opposite directions here so that they run into each other and make a 90-degree angle, which you may remember from geometry. A reciprocal property means that you need to flip the numerator and the denominator over. So that's what we're going to spend our time doing, is practicing making parallel and perpendicular lines. So the first situation says write an equation in slope-intercept form. Make sure you pay attention to what form that it's asking you for it in. And it says through a particular point and parallel to this. Now, if we're looking at this equation, it's very easy to see, since it's already in slope-intercept form, that our slope has to be 3/4. So the fact that we already know our slope makes it pretty easy, okay? Since it's a parallel slope, you're going to keep that slope as 3/4. And then you're going to use the 4 as your x and the -1 as your y. And then you're going to be solving for a new y-intercept. So we're going to leave this as plus b. And that's what we're going to solve for. So it's pretty easy. It's 2 steps. You're going to basically substitute, simplify, and subtract. So substitute, simplify, meaning multiply that 3/4 times that 4, and then solve it. Oops, I put plus 4. And then by solving it, I mean you're going to subtract this 3. So that leaves you with the equation y equals 3/4 x minus 4, excuse me, and that's in slope-intercept form. And you notice that the slopes are the same, and then you can move on. Now the next one says that you want a perpendicular line. So if you look at that slope and the slope is 9, and that's positive, that tells you that in order to get a perpendicular slope, you're going to have to do the opposite and reciprocal of that 9. So then your perpendicular, that's the geometric symbol for perpendicular, it's going to be a negative, and it's going to be a 1/9. Okay, so negative because it was positive in the original, and then 1/9 because you have to do the reciprocal. Now, in all these problems, you could care less about that old y-intercept, because your job with this new point is to find the new y-intercept. Again, you're going to substitute the x and the y from up here into the y equals mx plus b. So -3 is your y equals m is -1/9 times x plus b, and we're going to have to solve for that. So we substituted. Now we have to simplify, which means multiply these two things together. And then you can solve. So since that's positive 4/9, we're going to subtract 4/9 over here. Which gives me -3 and 4/9. So my final answer is going to be y equals -1/9. Make sure, because a lot of people forget and they go back to their original slope, make sure you keep your new slope So y equals -1/9 x minus 3 4/9. Now on the next couple problems, or this one in particular, you notice that your slope or your equation isn't in slope-intercept form. So the first thing you have to do is move it around to find what your slope is. So let's do that real quick. We're going to subtract our 3x and then divide by 10. And like we know, the only part we're interested in really paying attention to is that -3/10. So since it's a parallel situation, we're going to keep that slope the same. Fill in your x and your y values. So y equals m times x plus b. So we can simplify that. That is -15, positive 15 over 10, which is going to be 1.5. Then, so we substitute and simplify, now we can solve. So subtract that 1.5, and that's going to give you -0.5 equals b. So that being said, our equation is y equals -3/10 x minus 0.5. Okay. Now the next situation up here, you'll notice is a special case. So perpendicular to x equals 5. X equals 5, this represents, think about it, here's my x-axis, here's 5. We're talking about x equals 5 as a vertical line. So that means that we need a horizontal line, okay? So again, that means this is a vertical line. So if we want a perpendicular situation, we need a horizontal line. Well, if it's a horizontal line and the original one was x equals, then we're going to use a y equals number. Well, it gives you a particular point, so you have to look at what y number it gives you. So this is a problem that actually requires no work, just you understanding the concepts. So right away, I look and I see my y value is -6. So all I have to do is write down y equals -6. Similarly, let me just throw in here, if it had said a parallel situation to x equals 5, we would have used x equals 2. So make sure you understand that. All right, so worst case scenario, you don't get the equation of the line, it just gives you 2 points and says make it parallel to these 2 points, but go through this point. So the first thing that you have to do is take these 2 points right here and find their slope. So that's what we're going to do first. So first thing I'm going to do up in the corner is find the slope between those 2 points. So my slope for those 2 points is 2/3. And since I want a parallel situation, I'm going to use that 2/3 along with that new x and y, 2 and 3, and plug those in. So like we've done in the others, we set it up as y equals mx plus b and substitute our y, our m, and our b, and then we can simplify that. 2/3 times 2 gives me 4/3. And then I'm going to subtract that 4/3 over to the other side. Now 4/3 is 1 1/3. So when I move that over, that's going to leave me with 1 2/3. And then that's going to be my final equation. So on this one, take a minute, rearrange these 2 equations over here so that you can compare slopes. Because looking at A and C, you're trying to find which ones are parallel. clearly these two are not parallel, A and C. In fact, they're nothing related to each other. They're going to cross each other because their slopes aren't the same, but they're certainly not perpendicular because the only thing they have going for each other is that they're opposite. They're not reciprocals either. So let's take a minute, hit pause, rearrange equation B and equation D so that they're in slope-intercept form. Okay, so I took a minute and I rearranged these, so we need to compare all the slopes. So I've got 2/3 on part D, and I've got negative 2/3 on part B. So if I compare, the one that matches is going to be D. So my choice here would be D. Same thing here, but instead the line passing through which 2 points, sorry about no S, is parallel to the line. So you have to take a minute and you're going to find all your slopes for these until your slope matches this one. So first thing you have to do is find your slope of the original equation. So hit pause, find that slope, and then calculate the slopes of A, B, C, and D. So first thing you see is that I found the slope, or I rearranged the equation. The slope of this one's going to be 1/2. So now we're searching for which of the points comes up to produce a slope of 1/2. So I'm going to hit pause again. You guys calculate those slopes. Well, according to my answers, it looks like none of them work. I'm guessing maybe this is off by a sign in the original equation, and we were hoping that A would have been the right choice. Let's say we were going for perpendicular, then C would have been perpendicular. But based on this, there must be a little mistake somewhere. So that being said, that's the end of it. Make sure you guys come to class on Thursday ready to go.